Alright, 213.327 alignment. Uniformity at any point along the track is established by averaging the mid-chord offset value of the 9 consecutive points centered and around the point in which are spaced in accordance with the following table. A 31-foot chord length is the spacing for 7 foot 9 inch. 62 foot is a 15 and a half, and 121 is 31 feet. That means they're a quarter of each. For single deviation, alignment may not deviate for the uniformity more than the amount prescribed in the following table. The class 1, 6 through 7, and 7 and 8. 6, 7, and 8 have the 6 has a deviation 31-foot chord at 1/2, 62-foot chord 30 and quarters, and 1.5 at 124. 7 foot has a 1.5 chord at 31, 1.5 at 62, and 1 1/4 inch at 124 mid-offset chord deviation uniformity. 8 has class 8 track has a 1/2 at 31-foot chord, 62-foot chord, and 3/4 inch at 124 foot, and also class of track number 9. For 3 or more non-overlapping deviations, uniformity track alignment occurring with a distance equal to 5 times the specified chord length, each which exceeds the limits for the following table, each of the owner of the track to which of the subparts apply with the shall maintain the alignment of the track with the limits prescribed by each of the deviation. Alright, the deviation for the 31-foot chord of the uniformity may not be more than 3/8 of an inch for all 6, 7, 8, and 9. While deviation of 62-foot chord for class 6 is 1/2 inch, and 124 foot is 1 inch. Class 7 track has a 3/8 of an inch at for 31 foot and 62 foot chord, and 7/8 of an inch at 124 foot deviation uniformity mid chord offset. Also, class 8 and 9 are the same. And in some cases, the particular repeating of the noncompliance of alignment and anomalies, alignment condition may be difficult to locate without the aid of the qualified geometric require. However, the inspector have the responsibility to identify the non-complying of the geometry conditions whenever possible. Whether located through the visual automated means, the condition must be verified using the conventional methods. Inspector must be aware of the addition to the geometry car. Other automated inspection will identify the geometry anomalies contributed to the E-grade of the vehicle track inspection. Uniformity at any point of the length of the track is established averaging the measured by the mid-chord offset the values of the 9 consecutive points centered around the point which are spaced according with the table of this section. For example, the established uniformity of 31-foot chord with the inspector should make the point of the chord concerned with the 4 stations in direction with the total of 9 stations. Station 31-foot chord is set at 7 foot 9 inch intervals. Their mid-chord offset values are obtained with each of the station average with the difficulty determined with lines with a 124-foot chord in the fielding using the conventional manual methods. The method of determination uniformity is determined with the manner of the tangent spiral curves. Figure 6.2 illustrates the method of determining uniformity of a 31-foot chord measurement. You have your 9 sets on the other, 4 on each side, positive and negative, each with the stations going 31 feet, and then you have your mid-offset chords. The track safety standards establishes maximum limit of alignment of the tracks in class 6 through 9 tangent and curved tracks, including spirals, are measured with the 3 chords, the 31, 61, and 124 foot. The alignment deviation may be present for any more than one chord. The anomaly of the uniformity exists, and for more than one chord shall be reported with a signal defect within the line of noting describing other deviations, non-compliance with another chord. For example, the 5/8 of an inch deviation uniformity of a 31-foot chord. Note that the defective is also 3/4 of an inch deviation uniformity of 62-foot chord. The point of the greatest alignment, the deviation can you usually detect visually measured by the point of the mid-offset will be required for that. However, the inspector should be used the location to identify the automated inspection methods, but whenever the possibility to identify the location, deviation visually verified for the location. For curves class 6 through 9, alignment and condition may be either the non-compliance, either maximal allowable with 31-foot, 62-foot chord, or 124-foot chord. As shown in Figure 6.3, the certain alignment defects may be blind to some chords and invisible to others. For example, the 31-foot chord, particularly necessary to determine the short alignment of deviations, and the 124-foot chord is usually a vertically long wavelength. 62-foot chord is binding certain alignment deviation. The 31-foot chord would also be the short wave deviations. This line will be taught against the rail 5/8 of an inch below the railhead using offset blocks, and then becoming methods establishing line and with a laser. Similar methods may be used. Paragraph C. Establish alignment requirements of repeated deviation, 3 or more non-overlapping deviations which occur with a distance equal to 5 times the specific chord length. Each occurrence of the 3 or more deviations within the distance of 5 times the chord length. Each of the exceeds the letter of the table in accordance with the one of defect condition. Repeated alignment deviations may exist if the vehicle's nature resonance caused by diversely vehicle reaction. Although the repeated alignment deviations are rare, they usually identified with the automated inspection. However, the inspector must be aware of the significant repair alignment defects is inspected for one rail time at a time. If the inspector believes the geometry condition on the opposite rail of the same area may contribute to the excitation, the inspector should inform the railroad representative. Note the condition of the inspector report. The term non-overlapping is a common term that clarifies the concept of the relation with the track geometry. Inspection vehicles with one alignment swinging normally several midcords offset measured which exceed the specified threshold. However, the alignment deviation may be considered as repeating the defect. The chords themselves must not overlap. Figure 6.4 illustrates these repeating alignments. So you have these different repeating alignments. The concept is that one swing is not counted more than once. Multiple unit deviations may excite the harmonic motion of the vehicle. Multiple vehicles in 3 or more non-overlapping deviations from the uniformity track profile occurring the distance equal to 5 times the specified chord length with repeated condition. Not each alignment deviation is considered defective. However, the rare the case the deviation repeats beyond the distance of the 5 times the specified chord length, with the inspector shall consider all set of deviations as one exemption. However, the total length of the repeating condition occurs the feet must be reported along with the number of the repeating deviations and magnitude of each deviation. Figure 6.5. Defective codes 327.01 and through 327.03 are reserved. 327.04, the alignment of the track exceeds the allowable deviation of 31-foot chord of a single deviation. 327.05, the alignment of the track allows the deviation 62-foot chord over a single deviation. 327.06, the alignment of the track exceeds the deviation of 124-foot chord. 327.07, the alignment of the track exceeds allowable deviation for 31-foot chord for 3 or more deviations. 327.08, the alignment of the track exceeds the allowable deviation of 62-foot chord for 3 or more deviations. 327.09, alignment of the track exceeds allowable deviation for 124-foot chord for 3 or more deviations. 213.329 curves and elevation speed limitations. A. The maximum cross level over on the outside of the rail of the curve may not be more than 7 inches. The outside of the rail of the curve may not be more than a half inch lower than the inside of the rail. B. The maximum allowable operation speed for each of the curve is determined by the following formula. B max. The maximum allowable operating speed is equal to the square root of the actual elevation of the outside rail plus 3 in inches. The maximum allowable operating speed is equal to the square root of actual elevation outside of the rail in inches plus 3 inches of unballast divided by the degree of curvature of 7/10,000ths of an inch. Appendix A includes the table showing the maximum allowable operating speeds computed with accordance with the formula with the various elevations and degrees curvature track speed greater than 90 miles an hour. C. For the rolling stock meeting the requirements specified in paragraph D of this section, the maximum operating speed for the curve is determined by the following formula. The maximum allowable operating speed is the square root of the actual elevation of the outside rail in inches plus the actual unbalanced elevation in inches divided by 7/10,000ths of an inch of times the degree of the divided by times the degree. Your actual elevation for your 155-foot track segment is a body with a curvature determined the averaging elevation of 10 points through the segment of 15.5 foot spacing. If the curve of the length is less than 155-foot average points through the full length of the body with the curve exceeding the unbalanced elevation exceeds 4 inches, the maximum allowable operating speed applies to spirals both ends of the curve. The degree of the curvature is determined the average degree of the curvature over the same track of the segment as to the elevation. D. The qualified equipment may be operated with the curving speed determined by the formula paragraph C of the section provided with each of the specific class of the equipment to provide the operation of the Federal Railroad Administration with the railroad demonstrates that when positioned on the track with the uniform super elevation, that the actual elevation outside of the rail, reflecting the intended of the target, deficiency of the unbalanced elevation in inches. No wheel of the equipment to be unloaded to 60% or less of the static value of the perfectly level track of the passenger carrier equipment. To the roll angle measured of the floor vehicle of the horizontal does not exceed 5.7 degrees. When positioned on the track of the uniform 7-inch super elevation, no wheels unloads to value less than 60% of the static value of the perfectly level track of the passenger carrying equipment. The angle measured for the rolling axis between the floor of the vehicle and the horizontal does not exceed 8.6 degrees. The track owner shall notify the Federal Railroad Administration not less than 30 calendar days prior to the proposed implementation of the higher curving allowed when the unbalanced elevation above will exceed 3 inches. This notification shall be written and shall contain with the minimum of the following information: 1. Complete description of the class of equipment involved with the schematic drawings, the suspension system, the location of the center of the gravity above the top of the rail. 2. A complete description of the test procedures of the instrument using to qualify the equipment, the maximum value, usually the wheel, unloading the roll, and angles were observed during testing. 1. The test procedure must be conducted in the test facility whereby all the wheels on one side of the right or left of the equipment be raised or lowered by 6 or 7 inches. The vertical wheel of the loads under each of the wheels measured on each level is used to record the angle through the floor of the vehicle has been rotated. 3. The procedures of the standards in effect with related to the maintenance of the suspension system for a particular class of equipment. 4. The identification of a line segment which the higher curve speedings are proposed to be implemented. The track owner and operator's passenger commuter services provided passenger commuter services over the track and more than one track of the owner of the same class of equipment may provide with the written notification of the Federal Railroad Administration with written consent over the affected track owners. Application paragraph 8 does not apply with more than 6 inches of the super elevation recommended in the curve. Neither the paragraph is limited to the amount of the cross level and corners in the curve with the control unloaded on of the wheels of the high rail, especially on the low speed. The cross level limited, notwithstanding the standards established with the maximum cross level at the point of the curve, which may be not more than 7 inches. Then curves the cross level measured with subtracting the relative difference in height between the top of the surface of the tread and the inside of the lower of the rail from the tread outside of the high rail. The Associated Administrative Safety shall reach the decision regarding the railroad request for the approval level, cant, and deficiency of specific equipment type based on the staff review of the engineering information submitted by the railroad. When requested, headquarters regional of the track special, the inspector may make the ask provided with a memorandum containing with recommendation concerning the railroad request. Paragraph B prescribes the formula to be used with determining the maximum train velocity and curves based on the actual limiting the curve alignment and degrees of super elevation at the same point. Several combination of the curvature elevation resulting in the speed limitation may exist should be considered throughout the curve where determining with a clear compliance with this section. The formula in paragraph B of the calculating maximum level operating speed commonly referred to as the 3-inch unbalanced formula sensitive the permits for the 3-inch less super elevation that would be required for the equilibrium conditions at the speed of the actual elevation actual curve for each of a 155-foot track segment in the body with the curve determined by the averaging of the measure of the 10 points through the segment of a 15.6-inch spacing. Paragraph C permits the railroad to operate with the higher levels with a cant deficiency provided with the railroad submitted with the required engineering information, static lean, etc., static lean and tests, etc. The FRA Associated Administrative Safety approvals the left of the cant deficiency. Alright, to determine the basic vehicle performance and curves requires the static lean, the test indicated with the behavior of the vehicle and suspension components of the car located motive is placed when the entire vehicle stands on the track of the one uniformly higher than the other, causing the vehicle to lean toward the lower rail. The vehicle is responsible for this situation to determine the weight distribution and the presence of the free play and the stiffness of the overall suspension system. Equipment with tilting capability can use the tilting mechanism to reduce the rolling angle of the high level of the car that cant deficiency on the track of the given the elevation, the top head of the vehicle, the high center of the gravity of the very flexible soft suspension will lean at the more greater angle than the vehicle of the lower center of gravity vary, providing the super suspension system. The static behavior mimics the vehicle by response to the force encountered by the passing through it. Track curve of the cant deficiency. The particular test was selected because it was a very straightforward, particularly practical performance requires only the very basic measurement capabilities. Nevertheless, it provides very useful information about the vehicle performance and the motion of curves. The requirements of the rolling angle measurement and the static condition in effect with the limit with the steady state car body acceleration on the smooth curve no more than 0.1 gross or maximum intended with the cant deficiency inconsistent with 238.427 of the passenger equipment standards of the steady statement acceleration directly portion of the central figure experience passenger when the equipment is going around the curve too many G's can result in safety hazards occupation of the high passenger safe speed equipment. Inspectors should computate allowable speed through the curves to determine with compliance with the section. Report the defects when the train exceeds the allowable based on the formula. Speed becomes the more critical in surface condition, but deteriorated with the curve is the increase with the misalignment near the point of the limiting speed. But the inspector may determine the compliance with the surface of the standards of 213331. The alignment of the standards 213327, and the sum of the cases will be more respective. Where railroads have not been initiated with remedial action to bring the surface alignment of the track into agreement with the operating speed based on the standard of the 3 inches unbalanced, and the inspector will consider the violation work when the train speed exceeds 4 inches. The cant deficiency of the train operation has been approved with the FRA curving the speed producing more than 3 inches of unbalanced cant deficiency. Inspector should only consider the recommendation violent with the cant deficiency exceeding the approved level more than the marginal amount. For example, the FRA approved the 5 inches of the cant deficiency specific amount. Equipment inspector would not be recommended violation marginal 5.2.2, 5.4 inches of cant deficiency. Only other hand violations should be considered with a higher level. The following formula should be used to calculate the unbalance on the field of measurements and maximum authorized speed. The equipment unbalance versus the maximum allowable speed by 7/10,000 of an inch by the maximum height in inches or something. Normally curves at each of the high-speed track of the design. However, it is possible the curves that introduce the result of the maintenance of geometry degradation. In case the super elevation may not be the present, the trains may be experiencing the unbalanced condition, the deviation with the uniform profile, the uniform alignment outlined in Statute 213.331 and 213.30.27 will not preclude longer wavelength misalignment in order that the 200 feet and greater to resemble the characteristics of the curve being treated as the curve for which the unbalanced formula defines the section will be applied. The defect code 329.01, reserve 329.02. The operating speed exceeds the allowable 3-inch unbalance based on the curvature and elevation 329.03 and 04. Reserve 329.05. Operating speed exceeds allowable the FRA approved unbalance based on the curvature and speed elevation 329.06. Maximum cross level of the curve exceeds allowable. 213.331 track surface. For the single deviation of the track surface of each of the owner of the track in which the subpart applies with the maintain the surface within the track which is limited to the class 6, 7, 8, and 9. The deviation for the uniform profile either the rail mid-orientation 31 feet or may not be more than 6 and 7 1 inch and 8 3 1/4 inch and 9 and 1/2 inch. The deviation uniform profile for either the mid-orientation of the 60 mid-offset or the mid-offset chord of the 62-foot chord not be more than 1 inch for 6, 7, 8, and 9 3/4 inch for 9 inch. The deviation uniform platform either the mid orientation of 124 foot may not be more than 1 3/4 inch for 6, 7, 1.5 inch, and 1 1/4 inch for 8 and 9. The difference across level between 2 points less than 62 feet apart may not be more than 1 1/2 inch for 6, 7, 8, and 9. Uniformity profile establish placing midpoint with the specified chord at the point of the maximum measurement. However, the control of the harmonics jointed with the track with the staggered joints. The cross level differences shall not exceed 1 1/4 inch of all the consecutive pairs of the joints and created by 7 joints. If the track joints staggered and is less than 10 feet, it shall not be considered with having staggered joints. Joints will allow the 7 low joints outside of the irregular joint spacing that is considered the joints and proposed with a footnote. For the 3 or more non-overlapping deviation of the track surface occurring with the distance equal to 5 times the specified chord length with each which exceed the limits of the following table, each owner of the track into which the subpart applies shall maintain the surface of the track with limits prescribed for each deviation. Our classes 6, 7, 8, and 9. The deviation uniform profile of either the rail of the mid-orientated 31 feet chord may not be more than 3/4 inch for 6 and 7, class 6 through 7, 8 and 8 1/2 inch, 9 3/8. But the deviation for the uniform profile, either the type of the rail mid-orientation of the 60 foot mid-orientated chord of 62 foot may not be more than 3/4 inch for 6, 7, 8 and 1/2 inch for 9. Deviation uniform profile, either the rail mid-orientated with a 124 foot chord may not be more than a 1 1/4 inch for 6 inch for class 6, class 7 1 inch, and class 8 and 9 7/8 of an inch. It is an alignment of deviation uniform profile that must be checked by using 3/4 31 foot, 62 foot, and 124 foot. The profile condition may be in non-compliance with any of the all the chords of measurement or using all the chords required to cover the necessary wavelengths, and interest may be excited at the undesirable vehicle response. Uniform profile is different with the uniformity established for the alignment. In the case of the alignment, uniformity is described in Statute 213.327a, determined by the average midcourt or offset values in the 9 consecutive points centered around the point with however the uniformity provided was described in the foot 1 below the Table of the straight line placed across the deviation in such a manner as to the measure of the largest midpoint orientated. In the figure 6.6 illustrates the procedure using 62-foot cord depending upon the length of the profile perturbation at a particular cord may be inside of the span of the perturbation. Figure 6.6. Appropriate size blank, 3/8 of an inch. You got your 3-inch block at 62-foot cord with a mid-orient contacted at 3-inch block with 1.5 about minus 1 inch equals 2 inches of high elevation. Profile hump deviation. 62-foot cord distance between the string and the rail deviation profile dip of the deviation. Okay, multiple profile deviation may excite the harmonic motion of the vehicle. Multiple deviation, 3 more non-overlapping deviation, uniformly track profile occurring with a distance equal to 5 times the specified cord length. Refer to the statute 327 of the description. Non-overlapping the repeated position, not equal each of the profile deviation and considered with one defect. However, the similar alignment with the rare case where the deviation is repeated beyond the distance of 5 times the specified cord length. The inspector should consider all the deviation for the one exemption. However, the total length of the repeating the conditions must be reported along with the number of the repeating deviations when the magnitude of each of the deviation. Repeated profile defects is specified with one rail at a time if the inspector believes the geometry condition on the opposite of the rail same area may contribute to the excitation. The inspector should inform the railroad representative note the condition of the inspector report. As it is standard class 1 through 5, the warp conditions is equally valid if the contributed to vehicle vehicle twist and wheel climb. The difference across level between any 2 points less than 60 feet apart may not be more than limited as specified. Jointed track is not typically a high-speed track. However, the inspector should check the harmonic rock of the off the condition whether the several joints of the row are low as indicated with the footnote. Number 2, the joint stagger that is not identical stagger to the stagger such as the curve of the royal longer than original construction installed with the consider the harmonic calculation additional joints and introduced because the installation short rails are ignored in the evaluation of harmonic condition. Construction consisting of a 79-foot, 80-foot rail does not result in harmonic rock-off conditions since they are outside the vehicle or truck spacing. Figures 79-foot and 80-foot rail staggered with spacing less than 10 feet. The footnote is not applicable. The inspector should review the condition in compliance with the other track support surface parameters. Figure 6.7 illustrates the harmonic condition. The inspection shall carefully apply with the provision of the footnote. Adding acceptable remedial action to raise and tamp 1 or 2 joints of the middle of the consecutive low joints will break the harmonic. Alright, this shows the rail joints, 3.25 inches a half from the center of 1.5 inches. 5/8 of an inch, 1/2 an inch. Alright, your defect codes 331.0 through 01 through 06 are reserved. 331.07, the difference of the cuff level between any 2 points of the 62-foot part of any tangent exceeds the allowable. 33.01, the difference of the cross level between 2 points of the 62-foot part of the curve between the spirals exceeds allowable. 33.01 33.109, difference across level between 2 points of the level of the 62-foot speed spirals exceeding allowable. 33.1 10, 11, and 12 reserved. 33 with 13 cross level differences, 6 more consecutive pairs of the stagger joints exceedable allowable. 33 1 14 profile track exceeds allowable deviation. 31 foot cord of single deviation. 33 1 15 profiles exceeds allowable deviation. 62 foot cord of the signal deviation. 33 16 the profile exceeds allowable deviation for 124 foot cord for a single deviation. 33 1 17 the profile track exceeds allowable deviation. 31 foot cord for 3 or more deviations. 33 1 18 the profile of the track exceeds allowable deviation. 62 foot cord for the 3 deviations. 33 1 19 the profile exceeds allowable deviation for 124 foot cord and 3 or more deviations. 213 33.3 automated vehicle inspection. For the track class 7, the qualifying track geometry measurement system, the vehicle shall be operated at least 12 hours within 120 calendars with not less than 30 days between the inspection. For the class 8 and 9, it shall be operated at least twice within the 60-day period with not less than 15 days between the inspection. Of qualifying and track geometry measurement systems shall meet and exceed the minimum of design requirements and specify that the track geometry measurement shall be taken not more than 3 feet away from the contact point of the wheels carrying the vertical load, not less than 10,000 pounds per wheel. The track geometry measure shall not be taken or recorded on the distance based on the sampling interval, all of which not exceed 2 feet. The calibration procedure of the parameters assigned with the system will ensure the measurement of the recorded values accurately represent the track condition. The track geometry measurement recorded by the system shall not differ with the repeated runs with the same site at the same speed or more than 1/8 of an inch. The qualifying track geometry measurement system shall be capable of measuring processing necessary track geometry parameters at interval no more than 2 feet with enabled with the system to determine the compliance to statute 213.323 of the track geometry and 213.327 alignment, 213.329 curves, elevation, speed limitations, 213.331 track surface. A qualifying track geometry measurement system shall be capable of producing within 24 hours of the inspection output reports provided with the continuous plot of the constant distance axis of all the measured track geometry measures required in paragraph C of this section. Provide exemption report containing with a systematic listing of the track geometry condition for the constituting with the exemption of the class of the track over the segmented survey. E. The output of the reports required for the paragraphs under C of this section shall contain with the sufficient location identification information which enable the field forces to easily located indication exemption. Following track inspection performed with the qualifying track geometry measurement system, track owner shall, within 2 days after the inspection filed, verify and institute the remedial action with the exemption to the class traffic. Class of the track. Track owner shall maintain the period of 1 year the following inspection performed with the track geometry measurement system, copy of the plot exemption of the perimeter of the track summit involved with the additional records with specify the date inspection was made with the track summit involved with the specify the location remedial action and the date thereof, and for all the list exemptions for the class for the classes 8 through 9, the qualifying gauge measurement system, their GRMS, shall be operated at least once only annually with at least 100 days between the inspection contingency compared with the loaded track gauge of the unloading gauge when unloading the condition of the lateral capacity of the track structure and shall not permit the gauge widening ratio greater than 1/2 an inch. The gauge resistant measurement system shall meet the exceeding minimum design requirements for the specified. The gauge resistant measurement shall measure between the heads of the rail at an interval not exceeding 16 inches under applied vehicle load of the not less than 10,000 pounds per rail under applied lateral load, which provides with a lateral vertical load ratio of 0.45 to 1.25 load severability greater than 3,000 pounds but less than 8,000 pounds per rail loaded. Severability is defined by loaded servability defined by loaded lateral load to the fastener system pounds is equal to actual lateral load in applied pounds minus the coefficient of the friction between the rail tie and the assigned nominal value times the actual vertical loaded applied pounds. The measured gauge shall be converted with the gauge widening ratio as follows. Alright, your GWR, what is GWR? GWR. Your gauge widening ratio is equal to the load track gauge measured by the gauge resistant measurement system at the point of the application of load minus the unloaded track measured by the gauge resistant measurement vehicle at the point of no less than 10 feet for the lateral vertical load application divided by the actual load of applied pounds times 16,000. At least one vehicle is one train per day operating in Class 8 and 9 shall be equipped with the functioning onboard truck with the frame with the car body accelerometer. The truck owner shall have the written procedure of notification of the track personnel onboard accelerator meters on train with the Class 8 through 9 indicating possible track related conditions. For classes 7, 8, and 9, the instrumented car having dynamic response characteristics, the response of the other equipment assigned to the service's portable devices monitoring onboard instrument of the train shall be operated with the track of the revenue speed file frequency at least twice in 60 days, will not less than 15 days between the intervals. The instrumented car and portable devices shall be monitored vertically and laterally orientated with the accelerator meter placed near the end of the vehicle at the floor level. In addition, the accelerator meter should be mounted with the truck frame. If the car body or the lateral movement of the car body with the truck frame and the lateral safety limits in the following table, the vehicle track and interaction safety limits are exceeded, the speed will be reduced until these safety limits are not exceeded. For the track class 8 through 9 instrumented with the cars having dynamic response characteristics, the representative of the equipment assigned with the service shall be operated over the track of the revenue speed of the profile and annual not less than 180 days between the inspection. Instrumented cars shall be equipped with the function and instrumented wheel sets and the measuring the wheel rail forces. If the wheel rail force of the following table, the vehicle track interaction safety limits exceed, these speeds will be reduced until the safety limits are not exceeded. M. The track owner shall be maintained the most of the resistant exemption printouts of these exemption inspections under the paragraph K through L of this section, initially left blank. Alright, I'm going to take a break.